breast cancer. It's a disease that has touched countless lives, casting a shadow of fear and uncertainty. For decades, scientists and doctors have been waging a relentless battle against this formidable foe. Imagine a world where breast cancer is no longer a threat, where the anxiety of early detection fades into the background. This is the promise that the latest scientific breakthrough offers, a beacon of hope in the fight against this pervasive disease. Breast cancer is one of the most common cancers in women worldwide. It's a complex disease influenced by a tapestry of factors, from genetics and lifestyle to environmental exposures. For years, our main tools against breast cancer have been early detection through mammograms and self-exams, and treatments like surgery, chemotherapy, and radiation. The latest discovery, however, promises to shift the paradigm. It targets the very roots of breast cancer, aiming to stop it before it even begins. The magnitude of this discovery cannot be overstated. It's a fundamental shift in our understanding of how to prevent breast cancer. Imagine a future where women no longer live in fear of this disease. But how did we get here? Years of meticulous research, countless hours in laboratories, and the unwavering commitment of scientists across the globe. The journey began with a simple question. What if we could identify the very cells that have the potential to become cancerous and neutralize them before they transform into a threat? Scientists delved deep into the intricate workings of the human body, exploring the very building blocks of life, our genes. The human genome is a vast and complex landscape. Scientists knew that somewhere within this genetic library lay the secrets to breast cancer. They embarked on a quest, armed with the latest tools of molecular biology. Years of painstaking research led them down various paths, each offering tantalizing clues. They studied families with a history of breast cancer, searching for inherited genetic mutations. Each study added another piece to the puzzle, gradually revealing the complex interplay of genes and their role in breast cancer development. The pursuit of scientific discovery thrives on collaboration. Scientists from around the world joined forces, united by a common goal. This global alliance of brilliant minds proved to be a turning point in the fight against breast cancer. Imagine a vast network of researchers, each specializing in a particular aspect of cancer biology. They gathered at international conferences, sparking lively debates and igniting new avenues of research. One landmark international study involving thousands of participants proved to be particularly illuminating. Researchers collected blood samples from women with and without breast cancer, meticulously analyzing their DNA for subtle variations. This massive undertaking generated an unprecedented amount of data, a treasure trove of information waiting to be deciphered. The data from the international study revealed a fascinating clue. Scientists discovered a specific gene, BRCA-P, that showed consistent variations in women who developed the disease. BRCA-P seemed to play a critical role in the early stages of tumor development. Further investigation revealed that BRCA-P was an active player, producing a protein that interfered with the body's natural DNA repair mechanisms. Our cells are constantly bombarded with damaging agents, but our bodies have evolved sophisticated repair systems. The protein produced by BRCA-P seemed to sabotage these repair systems, allowing errors to accumulate. If scientists could find a way to block the activity of BRCA-P, they could potentially restore the body's natural defenses against cancer. The race was on to develop therapies that could target BRCA-P and its associated protein. The discovery of BRCA-P marked a paradigm shift in our understanding of breast cancer. It provided concrete evidence that breast cancer is a complex interplay of genetic predisposition and environmental factors. This new understanding opened up exciting new avenues for prevention and treatment. Imagine a future where women can undergo genetic testing to assess their risk and receive targeted interventions. Our bodies are intricate machines, constantly working to maintain a delicate balance. Every second, our cells divide and replicate, faithfully copying the vast amount of DNA contained within them. Occasionally, errors occur during DNA replication, or our DNA is damaged by external factors. Fortunately, our cells have evolved sophisticated mechanisms to detect and repair these errors. Think of our DNA as a long, twisted ladder, with each rung representing a specific sequence of chemical building blocks. When DNA is damaged, these rungs can become broken or mismatched. Our cells possess a team of specialized proteins that act as molecular repair crews, constantly patrolling our DNA for errors. One crucial DNA repair pathway is known as homologous recombination, particularly important for repairing double-strand breaks. Scientists had suspected a link between faulty DNA repair and an increased risk of cancer. The discovery of BRCA-P provided compelling evidence to support this link. BRCA-P produced a protein that interfered with a key protein involved in the homologous recombination pathway, RAD51. RAD51 plays a crucial role in the early stages of homologous recombination. The BRCA-P protein acted like a molecular mimic, binding to RAD51 and preventing it from carrying out its essential function. Imagine a construction site where a crucial piece of equipment is rendered unusable by a faulty component. The entire construction process grinds to a halt, leaving the partially built structure vulnerable to damage. This is akin to what happens at the molecular level when BRCA-P interferes with RAD51. The consequences of BRCA-P's interference with DNA repair are far-reaching. With the homologous recombination pathway compromised, cells are more susceptible to accumulating DNA damage. These breaks, if left unrepaired, can lead to chromosomal rearrangements, deletions, or duplications. Imagine a library where books are constantly being copied and distributed. Normally, errors are caught and corrected by vigilant librarians. However, if the librarians are incapacitated, errors begin to accumulate. Similarly, with compromised DNA repair, errors in the genetic code are more likely to persist. The disruption of DNA repair by BRCA-P can also make cells more sensitive to certain cancer treatments. The discovery of BRCA-P ignited a wave of innovation in breast cancer care. For decades, breast cancer care has been largely reactive. The identification of BRCA-P offered a glimpse into a future where prevention takes center stage. Imagine a world where routine genetic screening for BRCA-P becomes commonplace. This proactive approach to breast cancer care has the potential to save countless lives. Understanding a patient's BRCA-P status can guide treatment decisions, leading to more effective and targeted therapies. The discovery of BRCA-P has ushered in an era of personalized medicine in breast cancer care. For individuals found to carry mutations in BRCA-P, several options are available. Increased surveillance may involve more frequent mammograms or breast MRIs. Lifestyle modifications can also play a significant role in reducing breast cancer risk. In certain cases, chemoprevention or prophylactic surgery may be considered. The choice of which strategy to pursue involves a careful consideration of individual risk factors and personal values. Section 3. Navigating the challenges and ethical considerations. The discovery of BRCA-P is a major breakthrough, but it presents new challenges and ethical considerations. Genetic testing raises concerns about privacy, data security, and potential discrimination. Establishing robust legal and ethical frameworks is crucial. Ensuring equitable access to genetic testing and treatment is another challenge. The cost can create disparities in access based on socioeconomic status or location. Advocating for affordable and equitable access is imperative. Sarah's story embracing empowerment. Sarah, a graphic designer in Chicago, was vigilant about her health. She exercised, ate well, and scheduled checkups. Breast cancer shadowed her family. Her mother and aunt had battled it. The fear of inheriting it weighed heavily. The BRCA-P discovery brought hope. Sarah decided to undergo BRCA-P testing. The waiting was agonizing. She tested negative. Relief and empowerment followed. Sarah felt a renewed determination to prioritize her health. Maria, a retired teacher living in a bustling suburb of Los Angeles, had always considered herself lucky when it came to health. She had never experienced any major health issues and had breezed through her annual checkups without a worry. However, her younger sister Elena had been diagnosed with early-stage breast cancer a few years ago, at the relatively young age of 42. Elena's oncologist, knowing about the BRCA-P discovery, suggested that both she and Maria consider genetic testing. Elena's results came back positive for a mutation in the BRCA-P gene. The news was a blow to Elena, but it also provided her with crucial information that helped guide her treatment decisions. Her oncologist recommended a more aggressive chemotherapy regimen, given the aggressive nature of BRCA-P-associated tumors. Elena also opted for a prophylactic double mastectomy, a difficult but ultimately empowering decision that significantly reduced her risk of developing a new breast cancer in the future. Maria, faced with her sister's diagnosis and the knowledge that she too might carry the BRCA-P mutation, grappled with a difficult decision. Should she get tested, knowing that a positive result could have significant implications for her health in future? After much deliberation and conversations with her family, Maria decided to undergo testing. Her results came back positive, confirming her fears but also providing her with an opportunity to take proactive steps to protect her health. The discovery of BRCA-P has revolutionized our understanding of breast cancer, offering tools for prevention, early detection, and personalized treatment. Scientists are still exploring BRCA-P's role in other cancers and genetic variations. Imagine a future where genetic testing becomes routine for various health conditions. Advances in AI and data analysis could usher in personalized medicine. The potential benefits for human health are immense. The discovery of BRCA-P has illuminated a path toward a future where breast cancer no longer holds the same menacing grip on countless lives. Knowledge is power, empowering us to make informed decisions about our health and well-being. Imagine routine genetic screening identifying vulnerabilities early on, tailoring prevention strategies to individual needs. This is the promise of precision medicine, embracing the uniqueness of each individual. Treatments are meticulously crafted based on an individual's genetic makeup, lifestyle, and environmental exposures. This personalized approach dramatically improves outcomes, minimizing side effects and maximizing effectiveness. While the discovery of BRCA-P represents a quantum leap in our fight against breast cancer, it also unveils a vast landscape of unanswered questions, beckoning researchers to embark on new quests to unravel the remaining mysteries of this complex disease. Scientists are diligently working to decipher the intricate interplay between genes and the environment, seeking to understand how factors like diet, exercise, exposure to toxins, and even stress levels can influence cancer risk and progression. One avenue of intense research focuses on developing more precise and less invasive methods for early detection. Imagine a simple blood test that could detect the presence of circulating tumor cells or specific molecules that signal the presence of cancer at its earliest stages, long before a tumor is even detectable by current imaging techniques. Such advancements in early detection would be game changers, allowing for timely interventions and significantly improving the chances of successful treatment. Another area of active exploration involves harnessing the power of the immune system to combat cancer. Immunotherapy, a revolutionary approach that empowers the body's own defenses to recognize and destroy cancer cells, has shown remarkable promise in treating certain types of cancer. Researchers are now investigating ways to enhance the effectiveness of immunotherapy for breast cancer, exploring new combinations of drugs, personalized vaccines, and innovative strategies to overcome tumor resistance. The quest to conquer breast cancer is a testament to the power of collaboration, innovation, and the pursuit of a cure. It's a tapestry woven by researchers, clinicians, and supporters dedicated to eradicating this disease. It's a testament to humanity's spirit, our will to alleviate suffering. Recent advancements from BRCA-P to targeted therapies were unimaginable decades ago. These breakthroughs remind us that progress is possible, even against challenges. As long as minds collaborate and ideas emerge, hope for a future free from breast cancer burns brighter. This journey is a marathon, requiring patience, perseverance, and belief in science. Every grant, trial, and donation brings us closer to a future where breast cancer is a distant memory.